Hello, everyone. My name is Shabnam Watson. I am a BI consultant, speaker, and blogger. I have worked with SQL Server, a family of products for 20 years. I have been focused on analysis services and Power BI for most of the 20 years. I'm excited to be here tonight for this great conference. For this great cause. So thank you to the organizers and the producers. Thank you for the sponsors for putting this together. And thank you for you guys joining wherever you are. Good morning, good night, good evening. This session is about aggregations of Power BI. But before we get into that, just have a couple of quick slides. We have a slide. If you've been on this conference since earlier, you may have seen this already. By any chance, if you're just joining, please consider donating in support of UNICEF. Here's a slide for the sponsors of this event. Without them, these events are not possible. So thank you, sponsors. I have a blog that has material that are supporting material for this session. So everything that I'm going to show to you, I've detailed in my blog. You can see the link here on the screen. Also, I'm happy to connect with you on social media, Twitter or LinkedIn. Just send me a message and I'll be more than happy to connect and answer any questions. So this session it's a bit of an advanced session. So it's for someone who's done a little bit of modeling with Power BI and now wants to do a bit of optimizing the model. Although it's an advanced topic, it's not difficult to implement. So it's an advanced topic, but you're going to see it's very easy to put together and get started with. So I'm going to show you a number of slides just so that we get the concept of what the aggregations are. I'm going to use the AdventureWorks sample database. Hopefully you've seen it before. If not, it's a sample database available from Microsoft. You can download it. Most of the demos are based on off of it. So I'm going to use that AdventureWorks sample database. Start with direct query, storage mode. I'm going to explain all of this to you in a little bit. Then create some aggregations and use Dax Studio to see how the aggregations improve the performance of queries. So when you start working with Power BI, when you work within the Power BI desktop, most of the Power BI files that you open have a reporting component to it and a modeling component to it together. Sometimes the two, sometimes they are separate. So if you're working with bigger projects, it is best practice to separate the report part of it from the model part of it. The reason that I bring this up is that the aggregations are associated with the modeling part of it. So if you are working with Power BI file that's connected to a live data set that's been published to Power BI service, or if you're working off of analysis services, you're not going to see the feature that I'm going to show you. So this is associated with the model part of it. Also, something that some people get confused with is that aggregations are different than aggregation functions in DAX. So this is not about the sum, min, max. Those are aggregation functions. These are aggregations. They're objects that are going to help the queries run faster. So they're an optimization technique. They are nothing new. They're not a new concept. So you have probably used this concept in other reporting tools. So if you're, for example, if you have a table that stores 5,000 products, sales for 5,000 products, and let's assume that you have sales for every product at every store and every day. That amounts to about 3.6 billion rows. So you have a very large table, right? Now, if you're working with a reporting tool, let's say reporting services, and you try to create reports off of this table, the reports are not going to run fast. So an old trick in the data world is that you can create a summary table, and you can direct your queries, your SSRS reports to the summary table. So for example, you know that your report is only looking by year, by store, state, and by product group. So that's about 104,000 rows. That's a lot smaller. So at this point, it's just a matter of physics, right? If you're querying the smaller object, everything's going to be faster. Whether you're hitting disk or memory, it doesn't matter. If you hit the smaller object, everything's going to be faster. So you most likely have seen aggregations before in other tools. Now notice in reporting services, for example, you as the report writer are responsible to decide which one of these tables to use for which table, right? Now, in Power BI, how this is done is similar. So you have a detail table and you bring in an aggregation table. We're going to see the details of it, but for now, just think about it. So you have two tables, a detail table and a summary table. And the difference here is that once you configure the Power BI, the aggregation table in the model, at report time, it's Power BI that uses which table to use for which visual. So every visual that runs a query, Power BI decides which table to direct the queries to. If it can, it will use the aggregation table. If not, it will have to go and use the detail table. So ideally, you want your high-level queries to hit the aggregation table and the detailed queries to hit the detail table. Now, what are the benefits of this? Obviously, you will get improved query performance. The famous demo that's out there is by Christian Wade, where he shows how you can do this with a quarter petabyte of data. And you can just drag and drop the measures onto the report canvas and they just appear. And it's just quite fascinating. The reason that's working is because it's using aggregations behind the scene. Now, even though that's the ultimate use case of aggregations, that doesn't mean that if you have a smaller database data set, you're not going to benefit from it if you use aggregations. So aggregations can be used for anything that's expensive to pull into memory because of the time it takes to load, because of the amount of CPU, or just that you don't have enough memory to keep it in there. So the ultimate use case, again, that's used in that particular demo is something like what you see on the screen. It's a combination of tables. So it's the same data. You have your big IoT table that's sitting in the backend system. And then on top of it, you have another summary table that's perhaps a cluster, column store, index table. And some of the BI queries can use that. And then on top of that, there is a more summarized table that sits in Power BI's memory. And that's the one that's going to feed the visuals for the executive dashboard. And then Power BI will decide which one of these three it can use for each visual. So before I show you the demo, let's go over the table storage modes in Power BI. So when you create a Power BI model, you start bringing your tables into the Power BI model. One of the first questions that it asks you is that, do you want to load this table into memory? Do you want it to set it to import? Or do you want to use direct query, meaning that you want to leave the table in the back-end system and the Power BI layer acts as a semantic model. So import mode means your table is loaded into Power BI's memory. So Power BI is the semantic layer. It knows how to join the tables together. It knows how to write queries on your behalf, and it contains the actual data. The data is stored in a columnar memory-based storage system. It's called VertiPack. It's very fast. It is similar to cluster, column store indexes. And in such a scenario, all queries are answered from memory, everything's fast. Now, the other choice, as I mentioned, is direct query. With direct query, this time the Power BI just joins, it acts as a semantic layer. So the only thing that's storing is the number of columns and how to join them. When a user queries the model using a visual, Power BI creates a SQL query or whatever the backend language is, and it will submit it to the backend, and it's the backend answers the query, sends the data back to Power BI. Power BI will visualize it. Now, there's pros and cons to these storage modes. Import is best for most models because it's in memory, it's fast. However, there's some loading and processing time involved. So if you're working with data sets that don't fit into memory, or you have to be near real time, low latency, then direct query is a better answer because there's no data moving. And if you're working with large tables, they're not going to fit into memory, so you have no choice, right? So what if you can't make up your mind, right? So you want some of the features of one, but some of the tables aren't going to fit. Well, the good news is there's something called composite model. So composite model means that for each table, you can set the storage modes. So you don't have to say everything in import or everything in direct query. You can say some of the smaller dimension tables, for example, the product family of tables in this model that I have on the screen, right? They can be stored in memory. That way, if a user clicks on a dropdown for a list of product categories, it's going to load super fast. Same thing with date. But internet sales is not going to fit in memory, so we're going to leave it in the backend system. This is great because now you can have your smaller tables in memory and the bigger table in the backend SQL Server, right? And then if you have your aggregation table, the summary table, you can bring that into memory, right? So this is great. Now, if a query comes in and asks for sales amount by product, in this particular example on the screen, I have sales amount and product in the aggregation table. So that query can be answered from the smaller aggregation table. Everything's in memory, right? So Power BI can answer that query entirely from memory. This is great. However, this particular setup has created a problem for some other kinds of queries. So if a query comes in and it asks for internet sales by product and sales territory. Internet sales and sales territory are in the backend SQL Server. Product is in memory, in Power BI's memory. Unfortunately, this kind of join has to happen in Power BI's memory. So think about it, SQL Server is not able to do that join. It has to happen in Power BI's memory. Now, the reason we didn't bring in internet sales into memory was because it didn't fit in the first place or was too expensive. So we don't want this to happen. So we have hurt some other queries by doing this. The good news is there's still another answer from Power BI. So there is another kind of storage mode, and it's called dual storage mode. With dual storage mode, tables can flip back and forth for their storage mode. Depending on the query. What it really means is that Power BI knows that it can use a copy of the table in the backend, and it can also use a copy of it that it has cached in memory. This way, it will avoid doing those expensive joins in Power BI's memory. So, for example, if we set the 3 product tables into dual, now if a query comes in and it asks for product by sales amount by product and sales territory, the product table acts as if it was in direct query. So SQL Server in this example can do the joins. It's super efficient. It will resolve the query and send us the result. And Power BI will just render the result set. And if the other query comes in and asks for sales amount by product, then everything can be answered from memory, and this is great. So this is the ultimate setup that we're going to work towards. Now, there are a few limitations for aggregations in Power BI. They can only be set on top of detail tables that are in direct query themselves. So you cannot have a detail table in import and then set up an aggregation table on top of an import table. As soon as you configure a table as an aggregation table, it is no longer queryable to the end users. It will become hidden and only the Power BI workspace admin can query it. Aggregations are supported in both shared and premium capacities. They work with RLS, which is great. There's a cost involved with them, just like indexes and SQL servers, so you don't want to have too many of them. And once you create them, you want to monitor them, which is what we're going to do in a little bit. Now, a question that I get a lot is that how are aggregation tables different than other tables? And the answer is there's absolutely no difference. They can be a view in the backend, they can be a table, they can come from a flow. They're just like any other objects that you have in your data source. They can be, their storage mode can be direct query, they can be import, they can be created with an M expression. Power BI does not care how the table gets into the model. Any object that's in the model, you can configure it as an aggregation. Now, from that point on, you have to guarantee that it's actually answering the right, it's giving back the right values. You're guaranteeing that, but you can pick any table in the model. All right, so I'm going to switch to demo and show you, first of all, the data that I'm working with. This is a copy of AdventureWorks sample database, and I have all of this code on my blog. All I've done is that I've created a couple of views on top of some of the tables just to clean out some of the clutter. So for example, from dim date, you will see that I've only selected a few of the columns. The actual AdventureWorks database has a ton more columns. Same thing for, let's say, product. I've only picked a few of the columns, all right? And the other thing I've done is that I have created two actual tables that are going to serve as the aggregation tables. So, and the way I've created that is by a very simple group by. So the fact internet sales in my case has about 60,000 rows, and the first aggregation table that I've created has 288 rows. So it's by product key and calendar year. I have the sales amount, I have the sum of unit price and the count of unit price. These are all created here intentionally because I'm going to show you some examples, and I have a row count, right? Okay, and then the other table that I have is even a more summarized form of that. So this one only has sales amount by calendar year. So this one has 5 rows in it. So you're going to see that even for this small of a database, you're going to see a difference when I set up aggregations. You're going to have to use your imagination and see when you multiply this by thousands or millions, how much of a difference it's going to make. But even when you're working with such a small database, you can see some difference. All right, now let me open up the Power BI file. So this is a Power BI report that I've created off of that sample at AdventureWorks database. And I'm looking at sales amount by product category and year in this visual. And I have another high-level visual here, just sales by calendar year. And I have 2 cards here, sales amount and average unit price. Now, this is considered a very high-level report. My goal is to get all of these reports, all of these visuals to be answered from the summary tables that I've created. Instead of hitting the 60,000 row table, I want these to be answered from the 288 row and the 5 row tables instead. And to do that, I'm going to use aggregations. Now, when someone right clicks on here and says drill through, and then they go to the detail, then this visual, perhaps it's okay for it to hit the sales table, because now it's true that I'm pulling back detailed data, but I've put some criteria on it. I've limited it. So my query is a lot more selective. So this is a query I can send back to SQL Server and still get good results back. All right, so let's go and take a look at the model. So this is the same model that I was showing you before in the slides. And I'm going to bring in the aggregation table. So I'm going to go to recent sources. Oops, didn't like that. That's okay. So I'm going to go back. Let me try it one more time. It has forgotten my recent sources. That's okay. So I'm going to go to get data. I'm going to go to SQL Server. And we're going to go to localhost. And I'm going to leave it as direct query here. So I'm going to leave my storage option at first to direct query. Okay, so this is AdventureWorks. And I'm going to go and pick my 2 aggregation tables. I'm going to bring them in. So everything right now that I've started, this model, everything I had started with direct query. The way you can tell that this model is in direct query is that there's no data tab. There's no blade here where you can click in and see the actual data. And the other way you can tell is that at the bottom here, if I'm right now, I'm getting a message that says update available. If this was updated and this message was not here, you would have seen a direct query. It will tell you the model is in direct query. Okay, so I'm going to bring in these 2 tables as well. I'm going to say load. All right, so now I have 2 tables here. And I'm going to use these 2 tables. I'm going to set them as aggregation tables in one moment. But first, we can use some of the relationships. We're going to leverage some of the relationships in the aggregation setup. So I'm going to set up product key to product key. I'm going to connect these 2. I'm not able to connect calendar year to the date table because this is at day level, this is at calendar year, so I'm not able to connect these 2. And same thing with this one, there is no connection to be made in the model, right? Okay, so I'm going to open up Dax Studio before I configure this so that we can get a baseline without aggregations. Dax Studio, again, is a free tool. It's a great tool, has many different use cases. I'm just going to show you one of them today. So when you open it up, you can connect to any Power BI file that you have already opened. It will give you a list of them. So I'm going to connect. And now I can see my model. So I can see the list of my tables. I can query them. I'm going to go and open up my query here that I've saved, some sample queries here. Okay, so before I run this query, that is going to return the sales amount by product key. So this is one of the sample queries that I've used here. I need to click on the server timings tab. This server timings tab is what's going to give me information about behind the scenes, where I'm going to see whether or not the aggregation table was used. Okay, so make sure you have this one checked. All right, so I'm going to highlight this and I'm going to run this query. If I go to the results, I can see the sales amount by product key. Okay, and this query here, by the way, if you're new to Dax, all you got to do is you can go to your report and you can go and say view performance analyzer, go to your report tab, you can click on start recording, and then you can say refresh visuals. So you can open up each one of these. So if I click on it, it will tell me which visual it was, and I can go here and do copy queries. So this will give me the Dax query, and I can take that over here and I can do new query, connect to the model, and this is the query that is submitted, Power BI submitted. Now, Sometimes this query is more complex than what a human would write at at the first pass, and sometimes it's not. But it's a great way to grab the queries. If I copy this one, I believe this one's going to be a bit more human readable. So let's do this one instead. So you can see that this is the query that is submitted for that particular visual, right? So you don't have to know exactly how to write Dax to do this. So you can start with this query and run that and see if it's using the Dax, if it's using the aggregations, okay? And then because this is in direct query, you see that the Dax query is followed by a SQL query to the backend, okay? So let's skip that for a second. Go back to our query here. So we got sales amount by product key. All right, now if I go to the server timings tab, you can see that it gives me some information about how long it took, the formula engine, how much it was in the storage engine. We're not going to get into that, but it also shows me that the query that is submitted to the backend, right? So right now it's submitting a SQL query. And if I look at the SQL query, I can see that it went to fact internet sales, right? And it did a left outer join with the dim product on the product key because that's how we have defined a relationship, right? And that's how it ran. So now what I'm going to do is I'm going to take a screenshot of this. Okay, there we go. All right, I'm just going to put this to the side. Okay, so now let's go and configure that aggregation to see what happens. All right, so back to the model. I'm going to right click and say manage aggregations. Okay. So now I'm going to set the I'm going to focus on the sales amount because that was the only thing that's in that one query. Okay. When you get to the manage aggregations, you get one row per the column in your aggregation table. You don't have to set up, you don't have to populate everything in this window for it to start working. So you can just set up for some of the columns. So in this case, I want a query. If a query comes in asking for sales amount column of the internet sales, which is my detail table, I'm telling Power BI that it can use the sum of the sales amount from my aggregation table. Now notice that even though I clicked on this table, I can actually change it from here. I can pick any other table, so it doesn't matter where you click to get started. Okay, so that's all I need to know. Now, because there's a relationship between this aggregation table and a product table, I don't need to do anything else. Power BI is going to be able to figure out how to answer queries from this table with all of the product tables. So I'm going to say apply and go back to Dax Studio. So now you can see that immediately this table has become invisible. It's grayed out. It may be hard to see, but it is grayed out. So I'm going to rerun this query. And see what happens. So now it's a little bit different. So first of all, let's bring back that same. Okay, so let's see what happened here. So total went down from 23 milliseconds to 7 milliseconds. Now, all of this is not really tangible. It doesn't really make a difference for the user at these low numbers, but when you're working with larger data sets, this becomes significant. So let's see, what's the other difference? The other difference is there is a different event here. It's called a rewrite event, and it has been able to match it to the aggregation table. And if you click on the details, it will tell you exactly what column mapped to what column. And if you go on my blog, I go through this details of these requests. But now if you look at the SQL this time is doing a join from the aggregation table to the product table. So that's essentially it. That's aggregations. That's as easy. It's just as easy as this is to set up aggregations. So now that I've done this, not only this query, but any other query that's connected to the product set of family of products, product table is going to work with aggregations for the sales, because that's the only thing we've set up so far. Now, what does the miss look like? So let's say you set up an aggregation, you run it to see whether it hit or not. You can look at it and it will say it attempted, but it failed. And if you look at it, it will tell you the reason. The reason is missing. So we didn't set up anything for order quantity, so it's not able to use that. But if I query product category, enter the sales by product category, it's able to find the match. All right. So if I go back to the Power BI report, if I go to this part, I'm going to stop this and close this for now. So this card right now, this visual can be answered from the aggregation table because we have set up the sales amount. But I also want this one to be configured, the average unit price, right? So I'm going to go back to the model and right click, say manage aggregations. I'm going to find unit price. So I'm going to say for the sum of unit price, I'm going to find inner sales, unit price, use the unit price. So this is easier to read from right to left to understand. It's the detail column of the detail table. Instead, use the column of the aggregation table. So I hope that makes sense, but it's easier for me to read it from right to left. Okay, and for the count, use the count of unit price. Now, you are responsible to configure this correctly. If you give it the wrong column, it's going to use the wrong column. So you better pay attention here and check your results. Power BI does not know what the contents of these columns are. The only thing it does is that it checks for, let me see, okay, here. It checks for the type of the data column. So for example, it does not, you see it's grayed out. It doesn't let me pick sales territory key. And it gives you a little bit of help. It says this is the reason. If you can pick something, there's a reason for it that is preventing you from doing that. Okay, so I've set up the unit price count and sum here. I'm going to say apply, go back to Dax Studio, and I'm going to run this query. This query is going to give me the sum of internet sales price by product. So if I look at here, this is the query that I'm getting. For each product, I'm getting the unit price, right? And if I go to server timings, of course, this is a match because we just configured it, right? Same thing for the count. This is going to match. We just configured that. The question is it going to be able to answer this query? Is it going to be able to figure out the average, which is sum divided by count? So we know that, but do you think Power BI knows that? So if we were doing this session in person, I would have asked you to raise your hand or just say yay or nay. Right now, just think about it for a second and decide which one do you think. Do you think Power BI is smart enough, or do you think it still needs some improvements? So let's go ahead and run this. And it looks like it did that. So yay, it's great, Power BI is smart. So if you look at the details, it will tell you exactly that it looked for the unit price, and then it looked for the sum, and then divided by the count. And if you look at the SQL, you're going to see that it figured out, I'm not going to go into details, but it will exactly do that. So we'll go through the two. One time it will count, one time it will sum, and it's going to hit the summary table instead of main table to answer the query. All right, so far we have covered these two cards, but we have not covered these two visuals because these also have year in them, right? So how do we do that? How do we configure year? So let's go back to the model and go to manage aggregations. All right, let's take a look at the calendar year. Now, calendar year does not have a relationship with the date dimension. So we can't do the same thing that we did for the product. Notice that we didn't have to do anything for the product key here for the previous queries to be covered. So what I'm going to do here is I'm going to do group by date table, calendar year. So it's important that you pick the dimension table or date table. What we're telling Power BI is that if someone queries by the calendar year of the date table, you can instead use the calendar year of the summary table. Okay, so I'm going to say apply all, and hopefully if we did it right and we run this query, this is going to generate a hit. So this time it's able to hit. So this particular way of setting up an aggregation is called by using group by instead of with the relationships. And this was by filling out this one row. Okay. All right. So let's go back to the sample queries. I just ran that again. All right. So so by just adding that, so far we have covered that one last setting that we did is going to cover this. So right now, all of these visuals will be answered from that aggregation table. There is one more scenario for the aggregation table that I want to show you. It's another row in the properties window that comes up. If you go to try to set a filter, let's say on this visual, so let's say you want to put a filter on this, you want to show sales amount for a certain product. If I go here and I bring in the product key, I'm going to put it here. And let me go to basic filtering. Okay, there we go. So you see how it's counting the unique number of product keys, like how many rows it's getting for each product key. So to cover this kind of query, some of these kind of, this actually generates a query. It's not a visual query, but it's something that's being done in the back end. It looks like something like this. So let me run this first. Let's look at the result set. So for example, this is not the exact same query that I showed you, but this is similar. So for each color, we want to see how many distinct products are sold. So we're doing a distinct count off of the product key. Can we cover this in an aggregation? And the answer is yes. If we go here and look at manage aggregations, if you look at the drop down, there is no distinct count, right? There's min, max, count rows, but there's no distinct count. You can do distinct count by using group by. You know from SQL, group by and distinct count are the same thing. So this time, instead of using the dimension table like we did for calendar year up there, we use the detail table itself. And then we say product key, and this will cover that one query. So this one query, let's see, before it was a fail. Now if I run it, this query will generate a hit. So now we have a hit. For the distinct counts, there is some kind of performance threshold that once you have more than 2 to 5 million distinct values, then the performance of querying the actual table is better than hitting the aggregation table. So the aggregation table will not be considered in those scenarios. All right, so now, we have gone, so let me go back here, take a look real quick. So we have filled out everything. I haven't really used the row count here, but that's another kind that you can set up. So we have filled out everything here, except for there's one property up here called precedence, and we haven't used that, okay? So now let me go and configure the second aggregation table. I'm going to say, so if you remember for the year, I have to say calendar year. calendar year, and it's a group by. And for the sales amount, I'm going to say the sum of internet sales amount. So this is all that's in this table intentionally, right? So this is my second aggregation table. So now let me go back to here. And I'm going to rerun this query that we've run before. So before Power BI only had one choice, the first aggregation table. Now it has two choices because this is a calendar year, right? It can go to aggregation table 1 or 2. Now it is going to the second one. It appears that it's picking the smaller one, but that is not always the case. It is picking the second one because I added it second to the model. So you cannot rely on that on Power BI at the moment to pick the smaller table by size, right? So I'm going to back to the model and show you just as an example. So what if you wanted to actually direct the queries first to this table? In this case, it doesn't make sense because it's a bigger one, but I just want to show you as an example. So that's when you use the precedence property. Now I'm going to say apply all, and I'm going to go back to here and run the same query. And this time, even though the second aggregation table is smaller, it will consider the first one first. So that completes the set of properties in the aggregations that we've gone so far through them. So we've gone through all the possible settings that you can do in the aggregation. So now what I'm going to do now is I'm going to bring in this table into memory. So far everything's been in direct query. So now let's go and real quick switch these into import. Now when you switch something to import, it will give you a couple of warnings. One of them is that this is not reversible, so make sure you've saved your file. You cannot switch back. And the other thing is that it's going to take time, right? So if it's a big table, be prepared, it's going to take time. Okay, so this one is now in import, right? I'm going to do the same thing for this one. Now for this one, it's going to give me a couple of more messages, right? So it's going to say it's not reversible. It's going to say it's going to take time, right? It's going to take time, but it's also it is also warning me about weak relationships. Now remember when I was showing you the slides, I showed you the one scenario where one side was in import and the other side was in direct query. That's what it's talking about. It's saying that right now the product tables are in direct query, and this aggregation table, you want to bring it into memory. If you do that, this is going to be considered a weak relationship. And even if the data is available in this aggregation table, Power BI is not going to consider it because it knows that SQL Server can answer the query faster, even if it goes to the back end, right? So it's going to do that. So as a solution, it's offering to switch the storage mode of all these tables to dual for us. You can do it later or you can do it right now. So we're going to say, okay, go ahead and do it. And this particular message is not related to aggregations. It's just saying that because we were setting up another table in direct query, it's just warning us about query folding from one source to another for security reasons. Okay, so right now, these three tables are in dual. This table is an import. This table is an import, and everything else is in direct query. Okay. Now, let's go back and run a couple of queries. So, product category is in dual. When I run this generates a scan event. It's no longer a SQL event. This looks like SQL, but this is Power BI's internal query language, right? If I run evaluate sales territory, which is just like a simple select, this generates a SQL. So Power BI knows where to go for each one of these. Now, if I run this query that we ran before, that's going to return sales amount by product color. If you look at this, everything's being answered from memory now because product is in memory. The product dimension is dual, so it knows it can use a copy of it in memory. and it's hitting the aggregation. So it finds the aggregation and it generates a scan. So it can go from the aggregation table to the copy of the product in memory. So this is Power BI's internal query language. But if I throw in another attribute here, so by product color and sales territory, where sales territory intentionally left in the back end, right? If I run this query, now it's going to attempt to use the aggregation tables. It's going to fail. So it's going to revert back to using the actual detail table, and that one's back into memory. So now everything is going to be done in the back end with SQL Server. Okay, so that's the last query that I wanted to show you. Let me go back to the slides and just do a couple of review slides here. So hopefully you're still paying attention, you're still awake, or you're learning a couple of things here. All right, so
yes, Shabnam, indeed
okay.
we are.
Okay, good. Okay, so as a reminder, when you are setting up aggregations, there is two ways. So when you go to populate those rows in the properties window, you can either use relationships if they do make sense, or you can use the group bys. So the group bys are used for cases where you have tables that are at different grains, like a header detail table, or some of the big data systems. You cannot have relationships, so you are forced to use group bys in those scenarios. So this is the group by example I was explaining, and the other use case for the group by is for distinct count. So when you want to count the foreign key column on the detail table, you can use the group by. Now remember that the aggregation, when you're setting up aggregations, you're counting on relationships for them to be considered. So the aggregation table that we had based and the set of product tables. When you're counting on relationships, they are only considered when the aggregation is only considered when all of the tables that are involved in your query have the same storage. So all in direct query, all in import, or at least one side is set to dual, where it can flip back and forth. There's restriction in direct query that both sides must be from the same data source. So both of them must be in SQL Server or Azure SQL. They cannot be in two different places. Also, many-to-many relationships are always considered weak. So even if you have an aggregation in place that can answer the query, Power BI is not going to use it. Now, aggregations have a cost. So if they're an import, it takes time to bring them into memory. You spend some time to create them, whether they're in the back end or you create them in Power BI's memory. There's always a cost involved with them, just like indexes in SQL Server, right? So once you create them, you have to make sure that they're actually being used. Otherwise, it's an overhead. So if you create 10 aggregation tables for every visual, Power BI is going to check to see, can I use the first one? Can I use the second one? And then get to the 10th one and it can't use anything. So you wasted time. So you got to make sure they're actually being used. For one Power BI report, you can use Dax Studio, just like what I did. If you have a data set that you've published the service, you can actually use SQL Server Profiler or extended events, and you can monitor the event that I have on the screen to see if the aggregation tables are actually being used. If they're not, you can throw them out. They're not useful. Aggregations, if you have row level security, they work with row level security, but the row level security must apply both to the detail table and the aggregation table. If it only applies to one but not the other, it's not going to work. So let's say that if you have an aggregation, you have summarized your data by year, right? But You have role-level security that says certain users can only see products sales from United States. Certain users can only see product sales from UK. Then when you come in and you're one of those users, the rows that you can see are limited, right? But if you haven't applied that same role to the aggregation table, Power BI is going to prevent you from using that aggregation table because in our example, the aggregation table was by year and product, so it contained all sales territories, and Power BI knows that, so it will not consider that aggregation for users coming in through a role-level security. And finally, we looked at the precedent. So when you have multiple layers of aggregations, you want to guide it so that you are in control of which aggregations are being hit in what order. You cannot always, at the moment, you cannot always trust what Power BI picks. And regardless of where the aggregation tables are created, they can get out of sync, right? So if you have a summary table, you're summarizing it somewhere, right? It is your responsibility to make sure that the aggregation table is returning correct results. Power BI is not going to know, it's not going to try to detect whether things are out of sync or even you've used the right columns. You are responsible for them. There are some use cases.
Shabnam, yeah, sorry to interrupt. We are left with 10 minutes, 9 minutes to be accurate. Thank you. Just a reminder. I know you're on the flow.
Yes, thank you so much. Yes, so there are some cases where you cannot use aggregations when queries go row by row, and we are just at the summary, so good timing for the reminder. Just remember, aggregations are a great performance optimization technique. However, they should not be your first choice for improving the performance of your report. Follow all other best practices. If you're still having issues and if direct query is the right choice for you, the option is there for aggregation. I have some references here. I'm gonna upload these later. I'm not sure how they're going to be accessible to you. I believe there's going to be a link for you to be able to download the slides. And I have the feedback slide here. So I appreciate your feedback for me personally and also for the event. Please take a few moments to provide your feedback. And that's it. That's all I got for you. So hopefully you learned something. Hopefully you're going to go and try aggregations somewhere in one of your data sets, and you can see how easy they are to set up and get started with. With that, let me know what questions you have for me.